Hi everyone. So some of you came to me, asking question. So from those question or the conversation I have with those students, I feel I need to give this video tutorial here to clear some additional concept. The concept is about basically function and system. Okay, so in the first lecture we talked about function. Now, if I write y equal to f of x, right? Forget about system. Now this is a function, right? This is y is a function of x. Okay. Well, pure mathematics speaking, okay, x, right, can be a function itself too. So x can be a function of, let's see, a variable of t. Okay, can be a function of t, and then we can write x of t. So your original function will become f of x of t. So if you need, let's say give you an example here. Let's say y equal to x squared, right? X squared, or maybe just y equal to, well, let's just put it here, right? X squared. Okay. Then, right, if x of t, right, if x is a function of t, let's say maybe 2t plus 1. So ultimately, your y, right, is also a function of t. So the idea here, right, you see the function meaning in here, right? Well, how does that relate to a system, right? How does it relate to a system? So ultimately, basically, if I just purely look at this y or x, right? If I just purely look at this x of t or y of t, and I can see that they are simply a time function, right? Or function of variable t, right? So if this guy is sine of t, okay, and who knows, maybe this guy is just cosine of t, right? So they're just function and with certain kind of a signal, right? Now, when it relates to system, right, x of t is sinusoidal ones, okay, like this. When it relates to system, so what we do is we draw a box, right? Your input is x, right? We call input is x of t, okay? And output we see is y of t, okay? And we use this symbol here, okay, m, as an operator, okay, to represent the system, okay? So you could have a system, let's see, for example, a system of y just simply x squared, right? That's a system, okay? So for this here, this is very simple. If your input, right, if input x equal to 1, right, and output y equal to 1, and equal to 2, y equal to 4. Now this is like that. Now we have t here, which means, okay, if my x, right, if I represent my input x as a time function, who knows, maybe this sine x of t is a sinusoidal, right? It could be representing sinusoidal, right? Then the y, right, ultimately is also a time function. And of course, in this particular case, it'll be just sine, okay, square of t, or if you like, the sine t squared, okay? Some confusion here is this is x squared, so when it comes to ultimately in terms of a variable t, so this y, right, I can write as this, okay, so x squared t, or it's equivalent to this one here, okay? Equivalent to this. So this is a function of t. Okay, so let's make sure you clear that. Okay, now m at here, it's just a general meaning. This is a general representation of any system. So m is an operator which represents a certain system, and x of t represents the input here. So now this basically come to lead us to one of the assignment question here, which is y equal to d of not d, y equal to x squared of t dx over dt. Right. So one of the assignment question. In this question here, let's say even though I didn't write y of t here, now you should know that this is definitely will result this y as a time function, right? So it's like the idea is, right, y equal to m x of t. So x affects y, t affect x, so ultimately the t will affect the y, right? That's the thing. So x affects y and t affects x, so t affects y. However, x is your input, not t. So x is input, not t. Okay, not t. Okay. Now let's get back to this question here. In terms of showing whether this system satisfies additive or homogeneous property, I see many people making mistakes with this. Let's use additive property. So we need to check whether this guy, right, equals to this guy or not. So the left side here, okay, so the left side here, okay, as you can see now is inside the bracket is your input. Here the input is x of t. So the new input is x1 of t plus x2 of t. So in other words, right, what you need to do is, right, you need to find everywhere that you can find the x and replace that x with the new input x1 of t plus x2 of t. So the mistake that I can see that people making is on the denominator here, right, this dx slash dt. Now this guy is equivalent to dx over dt. Now you may not see, oh, dx, but you don't have x. Well, it's equivalent to writing like this, right? X is function of t, that's why you can do the derivative with respect to the time t. And this is also equivalent if you take this differential operator and inside a bracket is this, okay? So this is probably easier for you to look at it. And this is differential, this is an operator here, so we don't touch this one here. In terms of this left side here, right, so the left side, okay, we need to replace everywhere the x with x1 of t plus x2 of t. So that's the denominator, that's the numerator. Denominator, you're gonna have to change this also this x also to x1 of t to x2 of t. Okay, so this is the left side here. Okay, and ultimately you'll see that the left side is not the same as the right side, so additive, right, additive is not satisfied. Okay. Now homogeneous satisfied, the reason is because, okay, we are going to check homogeneous, we're going to check whether, right, the homogeneous is whether mcx of t is that equal to cm x of t. Okay, yeah. So again, what do we replace, right? You see, now the input is cx of t. So your left side, right, you're gonna have to replace your original x with cx of t. So which means you replace your x with cx, okay, and which happen to be, you take the c squared, take c out, c is a constant, so you can take it out of the differential operator, cancel 1c, so there, right? That's exactly equal to your right side, right? So your homogeneous is satisfied here, okay? So anyway, I think the key idea is, okay, number one, what is a function, okay? And what is function? How's that function idea, the idea of function relates to a system? And when you talk about a system, okay, what is input? What is output? Input, output, they are all functions, right? But they are function of t, basically. And output, y of t, is a function of x, right? So by the expression of the system, m of xt, okay? So output that is function of x. The next thing is, of course, is remember what to replace, okay? And the similar idea will apply to the time invariant, time varying system. Okay, so hopefully this helps. Okay, let me know if you have any more questions. Thank you.